Welcome to Anchor Academy. In this episode, we're going to look at grinding cutting tools with through coolant holes. We'll discuss how to program these tools in iGrind, and we'll set up and grind them on an Anker FX7 machine. Many modern cutting tools are designed with through coolant holes that deliver coolant directly to the cutting edge. The direct delivery ensures coolant reaches the area under the most stress, helping to control heat and improve cutting performance. The through coolant also aids in chip evacuation, which is especially critical in deep hole drilling, by flushing the chips away from the cutting zone. These coolant holes are typically sintered into the carbide blank. Because they're fixed within the tool blank, it's essential that the cutting geometry is ground in correct alignment with the coolant paths. This ensures that coolant exits exactly where it's needed and that the tool performs as intended. Proper orientation of the holes relative to the flutes, margins, or inserts is a key consideration in both design and grinding.
The first step to making a tool with through coolant is to program the coolant holes in iGrind. Open the blank editor and move to the coolant holes tab. Here we can select from 4 different types of coolant holes. Simple holes gives 1 hole for each flute on the tool. The user can define the hole diameter and the spacing radius from the tool center. We can also change the display in the i3DG window. Right now we can see the tool. We can change this to the blank only. We can have a translucent blank with coolant holes, or a translucent finished tool with coolant holes. And we can see with the simple holes that the holes follow the spiral that's programmed in the common parameters. The second style of coolant holes is the advanced holes. Advanced holes gives the user complete freedom in programming the coolant holes. The number of coolant holes and all parameters for each hole can be set independently. So we can change the hole diameter, spacing radius, lead, taper, offset angle, and we can configure the holes to either follow the tool spiral or be straight. And you can see that both these holes will act independently of each other. The next type of coolant hole is a single axial hole. A single axial hole provides a straight hole running down the tool center, where the user can simply input the hole diameter. Not really applicable to this type of tool, but can be used on end mills and other types of cutters. The final style of coolant holes is branched holes. Branched holes sets a single axial coolant hole which branches off to multiple holes at specified points along the blank. Multiple branches can be set with configurable branch and rotational offset angles.
Once we're happy with our coolant hole style, diameter, and positioning, we need to position the coolant holes in relation to the cutting edge of the tool. So to do this, we use the digitized coolant hole operation, and we can select the A offset from hole parameter. This parameter controls the angular distance between the cutting edge and the center of our coolant holes. Now that the coolant holes are programmed correctly and look good on the simulator, we need to consider how to locate the holes and grind the cutting features correctly on the machine. On the FX7 machine, we'll use the touch probe to locate the position of the coolant holes. The first thing to consider is the probe tip. In most cases for coolant hole digitizing, you'll need to use a right-hand probe tip, which has a chamfer on the right-hand side of the blade. This helps the stylus point access the small coolant holes more easily. If you're changing from a left-hand to a right-hand probe tip, make sure to run the probe qualification cycle from the probe menu. This cycle teaches the machine the size and position of the new probe tip so that it can digitize accurately. It's important for the digitizing operation parameters to be set correctly, or the touch probe might not locate the coolant holes. In the digitizing options, we can specify whether we want to digitize all the coolant holes or just a single hole. Digitizing all holes would be required if the hole spacing is unequal. We must input the number of coolant holes. We can also add repeats, so if the probe doesn't locate the holes in the nominal position, it will shift slightly by the incremented amount and repeat the process to try to find the holes. In the geometry section, we need to input the tool point angle and the distance from the tool center line to the hole centers. Once the touch probe locates the coolant holes, the positions are saved and used as a reference for the tool grinding. The cutting edges are ground in the correct location in relation to the holes. That covers the key points for successfully digitizing coolant holes with the Anchor software on the FX7 machine. Remember to check your probe tip type and take a few extra moments to check your digitizing parameters. This will help ensure accurate results and avoid mistakes. More information on coolant hole digitizing can be found in the iGrind user manuals. Thanks for watching.